Now here we have an expression function fx. But remember they have mentioned that y equals to fx. So that simply means all we have to do is we have to think of this as a shortcut for y. So saving space. So when we write here question number A, so y is really x into x plus 1. So we know we have to simplify this before we can differentiate this. X into x is x squared, x into 1 is x. So let's find the gradient. We have to find the gradient of the curve. Gradient is dy by dx. So the derivative of y is dy by dx equals to the derivative of x squared is twice x plus 1. Now we found an expression for gradient. We need to find the gradient at the point A. At the point A, we have the value of x 0 and the value of y 0. So the value of x is only needed for finding the gradient. Let's plug in the value of x here. So we get 2 into 0 plus 1 equals to 1. So the gradient is 1. So remember, we found the gradient of the curve at the point A. At another point, the gradient of the same curve would be different. Now let me say something about when we differentiate y, the derivative is written as dy by dx. What about differentiating fx? After all, they're writing y equals to fx. The derivative of fx is written as f prime x. Now be very careful. This is f a little minus 1x. This is called the inverse of the function. But when we write f with a little dash over here, we call it the derivative or the first derivative of fx. So it is very important to remember f prime x and f inverse x are very different. F prime x on the other hand is the same as dy by dx. They are the same. So if we do another example, let me do number B over here. So that means this time let me write, instead of writing dy by dx, let me simplify fx. It's the same thing, makes no difference. So we can write 2x divided by x squared to simplify the expression. We can write 2. So x to the power 1 minus 2. This is the indices rule. You subtract the power and we bring the value of x squared upstairs. So we write 2x to the power minus 1 minus 6x to the power minus 2. So the derivative or the gradient f prime x d by dx of fx is f prime x. So 2, this will be minus x to the power minus 2 minus 6, this will be minus 2 x to the power minus 3. Minus 2 minus 1 is minus 3. Let me write this down as positive power. So this becomes x squared. Minus 6 into minus 2 becomes 12. This becomes x cubed. So therefore now we have to find the gradient at the point A again. So at A, this time the x coordinate is 3. So x equals to 3. So let's find the gradient. So f prime 3, just the different notation, is the same as dy by dx. Minus 2 divided by 3 squared plus 12 divided by 3 cubed. So this would be minus 2 by 9 plus this would be 12 by 27. So this turns out to be 2 by 9. So the gradient of the curve is 2 by 9. So this is the same way of doing the sum. Now if I did the sum by writing dy by dx instead of fx, let me now remove this. So instead of fx, so I would be writing y. Instead of f prime x, I would be writing dy by dx. Instead of f prime 3 here, so we are going to write dy by dx. So see, there is not much of a difference by doing a sum in terms of a function or doing in terms of dy by dx. Now let's do one more sum. Let me do number D. So number D is, let me use y since y equals to fx. So y equals to 3x minus 4. So this is x squared downstairs and we bring it upstairs to the power minus 2. We have to find the gradient of the curve at the point 2, 5. So dy by dx, so the derivative of y is dy by dx. So this would be 3. Let me do this directly. Minus 4 into minus 2 is plus 8. X to the power minus 3. So this would be 3 plus 8 by x cubed. So at the point A, the x coordinate is 2. So at A, x equals to 2. So we can write dy by dx equals to 3 plus 8 by 2 cubed. So 3 plus 8 by 8, which is 3 plus 1. So the gradient of the curve at the point A is 4.